Hello everyone, welcome back to my YouTube channel. So in this video, let us start with a practical transformer on no load from the subject transformers and generators module 1 along with the phasor diagrams. Okay, so let us consider a transformer which is having primary winding and secondary winding. So it is connected across voltage source P1. Whenever the supply which is given to the primary winding of the transformer current starts to flow, that is I1. So due to the flow of this current, flux which is produces due to thumb rule. So to get the direction of flux, we'll be using the thumb rule. The flux will be produces, and this flux is linking with the secondary winding of the transformer. So due to this linkage of the flux, current is induced in a secondary winding of the transformer. Hence, EMF is also produced in a secondary winding of the transformer. You can call this E2 as a mutually induced EMF. And also E1 which is produced in the primary side, you can call that as self-induced EMF. Whereas the primary winding is having N1 number of turns, secondary winding is having N2 number of turns, and the main flux is phi. The word it says transformer on no load means there is no load on the secondary side. So which means that you can observe there is no load in the secondary winding, hence current flows to the load is 0. That is I2 is 0. But there is a V2. Okay, so now I2 is 0. So whatever the current which flows from primary side, we can call that as a no load current. So I1 is nothing but no load current. You can also call that as I0. So I1 is nothing but no load current, current which flows during no load. I1 equals I0. Okay, so this no load current is having now two main components. Because of this open circuit in the secondary side, this no load current I0 or else no load current is having two components. One is IC, you can call that as core loss component, core loss component, and another one is IM, you can call this as magnetizing component, magnetizing component. So what this core loss component and magnetizing component will do means that if there is no load in the secondary side means I2 is 0, so that copper loss in a secondary winding is almost equal to 0, but it is having iron loss in a secondary side. Similarly, in a primary side, a small amount of copper loss will be there and also iron loss will be present. So that if there is no load means iron loss is present. To produce that iron loss, this component is responsible, that is IC. IC, which is or else a core loss component, which is responsible for or else which is responsible to produce core loss. So IC is responsible to produce core loss. Responsible to produce core loss or iron loss, whereas the core which is made up of iron can also call that as core loss or iron loss. And one more component, that is magnetizing component, and it is responsible to produce alternating flux. Responsible to produce alternating flux. So IM is responsible to produce flux, IC is responsible to produce core loss or iron loss. So now how we'll write a phasor diagram. So now you can see to draw the phasor diagram, before that this no load current I0, now this is nothing but a vector addition of magnetizing component plus core loss component IM and IC. So now you need to write this IM and IC. Before that, I will write the phasor diagram. For this, flux is a reference because it is linking both primary winding as well as secondary winding. so that a flux is responsible to produce, or sorry, the flux is a reference. So now flux phi is reference. The phasor diagrams for practical transformer on no load. Okay, flux is a reference. Which is responsible to produce flux? Im is responsible to produce flux. And Im and this core loss component IC, which are always quadrature in nature. IC and Im, which are always 90 degree to each other. And this IC is in phase with V1, and this V1 which leads pi at an angle of 90 degree, and E1 and V1 which are opposite direction according to Lenz's law. V1 equals minus E1 according to Lenz's law. And E1 and E2 which are always in phase with each other, and this E1 and E2 which always lags pi at an angle of 90 degree. So if you are adding this IC and Im, you'll get I naught. This is your I naught. And the angle between I naught and V1 is pi naught. Okay. So this is how we need to write. So now we can consider this triangle OAB. From this triangle, you can able to write the components IC and Im. So this IC is IC and Im, which are velocity components. This IC you can write it as I naught cos phi naught, and this Im you can rewrite it as I naught sine phi naught. Okay, so the total power which is given by W is nothing but Vi cos pi for single phase transformer, V into I naught into cos pi naught for no load current, sorry, for no load on the secondary side. So I can write as V into I naught cos pi naught is nothing but IC. This is your power in terms of watt in case of transformer under no load conditions. Okay, so this is what you can see a practical transformer on no load. Okay, so if you're having any doubts regarding this, feel free to write in the comment box. And if you want, you can take screenshot. A very simple concept. Before that, a basics of transformer, everything you guys know, I think. If you don't know, have a basic knowledge regarding that, means please go through the elements of electrical engineering playlist. There you'll get to know. So if you really like this video, do subscribe and share maximum to your friends. If you're having any doubts, write in the comment box. Thank you and have a nice day.